NASA says its Voyager One probe, the most distant human-made object in the universe, is sending usable information to Earth again.
Its 36-year mission to explore strange new worlds.
NASA's Voyager One just sent us a shockwave of revelations. Literally, it uncovered a magnetic field beyond our solar system's edge that's far stronger and more tangled than anyone ever imagined. This discovery flips our understanding of the universe and raises urgent questions about the safety of deep space travel. Voyager didn't find a peaceful void. Instead, it hit a chaotic storm of cosmic rays. Tune in to witness a revelation that could shake the very foundations of our existence. Shocking discoveries at heliopause. Think of it like finding out the backyard fence isn't just a fence, but an electrified web of laser wires. Scientists thought the sun's magnetic pull would fade into nothingness past a certain point. But nope, this magnetic field is beefy, complicated, and ready to mess with everything we thought about space travel, cosmic radiation, and maybe even the universe's true nature. But here's the twist. Voyager 1 found something even stranger. But wait, there's more. This isn't just science class trivia. This discovery could mean big changes for how we protect Earth from cosmic radiation, plan future space missions, and dream up our sci-fi-inspired plans for colonizing other planets. Or, it could mean we're up against something dangerous and totally unknown. No pressure, right? Sitting pretty over 14 billion miles from Earth, the spacecraft crossed into interstellar space back in 2012, leaving behind heliopause, a fancy term for the invisible border where the sun's influence peters out. Scientists expected a serene, boring void on the other side. Instead, its instruments lit up like a cosmic Christmas tree, detecting chaotic phenomena that don't fit our current understanding of the universe. These are high-energy particles zooming through space, often born from violent explosions like supernovae or black hole dramas. Our solar system's protective bubble was supposed to fend off most of these space bullets. But surprise, the spacecraft recorded an unsettling spike in cosmic ray levels after crossing heliopause. Not a little hiccup, but a big fat red flag. Imagine thinking your house has bulletproof windows, only to find out they're paper thin. That's essentially what's happening here. NASA and other space agencies are scrambling to make sense of this. It's not just about exploring new frontiers anymore. It's about survival. Private space companies like SpaceX, which are gung-ho about sending humans to Mars and beyond, might need to pump the brakes until we figure out how to shield astronauts from these unexpected hazards. Here's where it gets weirder. The spacecraft's instruments have detected bizarre fluctuations in the magnetic fields and plasma waves beyond heliopause. Instead of a smooth transition into interstellar space, it's more like hitting a patch of cosmic turbulence. This isn't just bad news for future space travelers. It's a fundamental challenge to how we understand the universe. Scientists have to rewrite the rulebook, and honestly, they're probably wishing they had a cosmic instruction manual right about now. And then there's the cosmic radiation. The discoveries hint that the sun's protective bubble isn't as reliable as we'd hoped. High-energy particles are sneaking past heliopause, and that's bad news for more than just space travelers. The ongoing revelation of rising cosmic radiation intensity also leads to crucial concerns about its impact on human health. Astronauts spending months or even years in deep space will have to face this invisible enemy. Prolonged exposure to cosmic rays can damage cells, increase cancer risks, and even harm the nervous system. Without proper shielding, our brave space explorers might end up paying the ultimate price. This isn't some distant, future problem. It's an immediate and very real challenge. The spacecraft's ongoing journey also raises some uncomfortable questions about the ethics of space exploration. If we can't guarantee the safety of astronauts heading into these hazardous regions, should we even be sending them there? And what about the dream of colonizing other planets? Suddenly, that dream feels a lot riskier when you factor in lethal radiation and unpredictable magnetic fields. Are we sending people into a cosmic meat grinder without fully understanding the dangers? As if all that weren't enough, there's a chance we're witnessing the early signs of a larger cosmic event. If the heliosphere is weakening or changing in some fundamental way, it could have ripple effects across the entire solar system. Think of it like a dam starting to crack. The implications could be catastrophic, not just for space travel, but for life on Earth as we know it. The spacecraft's power supply won't last forever. Scientists estimate it'll go dark by 2025, leaving us with more questions than answers. But its legacy is already secure. By venturing into the unknown, it has shattered our assumptions about interstellar space and opened up new avenues of exploration. The discoveries it's made, and continues to make, are a reminder of just how little we know about the universe. Adding to the intrigue, the spacecraft has also begun detecting strange patterns in the distribution of cosmic dust particles. These particles, far more abundant and energetic than predicted, have baffled researchers. What's causing these fluctuations? Could they signal the presence of unknown phenomena, perhaps even new types of celestial objects lurking just beyond our detection capabilities? Each new data packet sent back feels like a tantalizing clue in an ever-deepening mystery. The silent void erupts with bursts of unexplained heat, strange heat bursts seen at the edge of space. Another groundbreaking revelation from the spacecraft concerns the temperature gradients beyond heliopause. Contrary to previous assumptions of a relatively cold uniform region, it has recorded sporadic heat bursts, some suggesting the presence of previously unrecognized energy sources. Could these bursts come from distant stars, unseen interstellar winds, or something far stranger? Theories abound, but definitive answers remain elusive. Meanwhile, its resilience itself is a source of inspiration and awe. Launched in the late 1970s, the spacecraft was never meant to operate for so long. Its continued functionality speaks volumes about the brilliance of its engineers. Operating on dwindling power reserves, it has required a series of ingenious adjustments from mission control to keep its instruments running. Every adjustment feels like wringing one last drop of insight from a well that should have run dry years ago. As its mission reaches its twilight, the broader implications of its findings are becoming harder to ignore. Humanity's place in the cosmos feels simultaneously more precarious and more thrilling. The discoveries enabled, magnetic anomalies, cosmic radiation spikes, unexpected heat sources, and peculiar dust patterns, paint a picture of a universe far more dynamic and unpredictable than we ever dreamed. The critical question now is how we use this knowledge. Do we treat it as a warning, a reminder of the dangers lurking beyond our planetary neighborhood? Or do we see it as an invitation to push our boundaries even further, armed with the insights gained from decades-long odyssey? The answer could define the next chapter of human exploration and survival in space. Its findings could redefine everything we thought we knew about space, from the way we explore it to how we protect ourselves from its dangers. Whether it's a thrilling new frontier or a warning sign of cosmic threats to come, one thing is clear: the universe is far stranger and more complex than we ever imagined. Back in the late 1970s, NASA launched two little explorers, Voyager 1 and 2, on a mission to snoop around our solar system's backyard. At first, these tiny tech-packed machines were all about snapping photos and grabbing data from our neighboring big shots, Jupiter, Saturn, Uranus, and Neptune. But they didn't just stop there. These overachievers went rogue, in a good way, and are now cruising through parts of space we'd barely even imagined. They're spilling some wild secrets about what's out there. Initially, the mission seemed straightforward. Just peek at the outer planets, send back some postcards, and call it a day. And they nailed it. The close-up views of Jupiter's swirling storms and Saturn's iconic rings were breathtaking. Scientists were geeking out over every little detail the probe sent home. But as the planets faded into the rear view, the mission kept trucking along, heading straight into the unknown, like cosmic daredevils diving headfirst into uncharted waters. The first breakthrough came when the spacecraft crossed this so-called edge, heliopause, in 2012. The region wasn't some boring, empty wasteland. Instead, it's packed with super-dense plasma particles zipping around like they own the place. Not to be outdone, its sibling followed suit in 2018 and backed up these findings, showing that this border zone is far from simple. It's a wild party of fluctuating magnetic fields and turbulent waves that'll leave any tidy space theory in tatters. Heliopause isn't even the true end of our solar system. Sure, it marks where the sun's solar wind starts to lose its grip, but the sun's influence stretches way further than that. Picture a giant, invisible bubble, the Oort cloud, full of icy debris, stretching up to 100,000 times the distance between Earth and the sun. For context, heliopause is just one tiny fraction of that, sitting at a measly 150 times that distance. Basically, the solar system's backyard is way, way bigger than anyone thought. And it's not just about size. As the mission dives deeper into the abyss, it's picking up some seriously strange vibes. Turns out, interstellar space isn't the calm, uniform expanse we'd imagine. It's a hotbed of activity, with magnetic fields twisting and plasma waves rippling like some kind of cosmic rave. This has scientists scratching their heads and wondering, if interstellar space is this chaotic, what does that mean for the rest of the galaxy? For space exploration, this new knowledge is a game changer. The area where the solar wind tussles with interstellar particles isn't just a random curiosity, it's a key challenge for future missions. Cosmic radiation out there is no joke, and it's way more intense than anyone expected. The data shows that designing spacecraft to survive this kind of environment will require next-level engineering. Shielding against this cosmic chaos isn't just about protecting fancy equipment, it's about keeping future astronauts alive if they ever venture this far from home. Speaking of keeping us safe, the heliosphere, this solar-powered bubble that's supposed to protect Earth from cosmic rays, might not be as reliable as we'd hoped. The findings hint that it's more fragile and changeable than anyone guessed. A slight wobble in the sun's activity, or a nudge from interstellar forces, could reshape the bubble, leaving us more exposed to dangerous radiation. That's not just a problem for space missions. Changes in cosmic ray levels could mess with Earth's atmosphere, impact satellites, and even throw a wrench into global communication systems. Our solar system's fragile shield is not what it seems. Voyager explains the sun's protective bubble. Beyond the practical stuff, there's something downright poetic about the mission's journey. It has left the solar system's hometown and is now floating in a region where the sun is just another tiny dot among countless stars. It's like an interstellar ambassador, sending postcards from the fringes of the galaxy. Every bit of data sent back reminds us how small we are in the grand cosmic picture and how much more there is to explore. Of course, all good things must come to an end. The power supplies are running on fumes, and by 2025, the spacecraft will likely go silent. But its legacy? That's eternal. It didn't just push boundaries, it obliterated them. It has redefined our understanding of the solar system, inspired countless new questions, and proven that humanity's curiosity knows no bounds. The story is one for the ages, a tale of discovery, resilience, and the relentless drive to explore. Even as its signals fade, the journey will continue to light the way for future generations. After all, the universe is vast, mysterious, and packed with surprises. And thanks to this mission, we've got a pretty good map to get started. As we dive further into the details of the heliosphere, it becomes clear just how much this mission reshaped our understanding of this protective bubble. The heliosphere acts like a shield, buffering us from the high-energy cosmic rays that whip around interstellar space. Scientists thought it worked like a neat barrier, but the data showed that this zone is more like a flexible, breathing boundary. It shifts, changes, and reacts depending on the sun's activity. During solar maximums, when the sun is throwing off more intense solar winds, the heliosphere expands outward. But during quieter times, it contracts, leaving more of the solar system exposed to the galactic environment. This breathing nature of the heliosphere raises questions about how it might affect Earth over time. If the heliosphere weakens or shrinks, more cosmic radiation could bombard our planet, potentially influencing not just technology, but also climate and even biological processes. Cosmic rays can interact with Earth's atmosphere in subtle ways, sparking chemical reactions that might have long-term impacts. Understanding this dynamic isn't just a cool scientific puzzle, it's essential for planning how humanity interacts with space in the future. The work also brought new insights into the heliosheath, the turbulent zone at the outer edge of the heliosphere where solar wind meets interstellar medium. This region isn't just a chaotic mess, it's a goldmine of information about how stellar winds interact with the broader galaxy. Shockwaves here, where the solar wind slows down dramatically and mixes with particles from interstellar space, help scientists study how stars, in general, might influence their surroundings and how stellar systems exchange energy and matter with the galaxy. Even the composition of the particles detected gave scientists a lot to think about. The probes found that the interstellar medium, the stuff between stars, is denser and more complex than anyone had expected. It's not just a thin soup of hydrogen and helium. It's a dynamic environment with varying densities, magnetic fields, and particle flows. This complexity suggests that interstellar space might play a bigger role in shaping galaxies than we thought. Looking ahead, the findings set the stage for future missions into interstellar space. Scientists are already thinking about what comes next. More advanced probes designed specifically to study the interstellar medium in greater detail, with instruments tailored to survive the journey. These missions could provide deeper insights into the structure of the galaxy, the behavior of cosmic rays, and the life cycles of stars. The discoveries also tie into one of humanity's oldest questions. Are we alone? By studying the conditions at the edges of our solar system and beyond, scientists gain a better understanding of what kinds of environments might support life. If interstellar space is this dynamic and rich, could other regions of the galaxy hold surprises, maybe even signs of life? These are the kinds of questions that the mission helps us start to answer, even as it drifts into the silence of deep space. This mission reminds us that exploration isn't just about the destination. It's about the journey, the questions we ask, and the ways we push ourselves to understand the unknown. These little probes have traveled farther than anything humanity has ever created, and their legacy will inspire countless generations to look up, wonder, and reach for the stars. The spacecraft has revealed that the heliosphere is constantly under assault from interstellar forces. Galactic winds, intense bursts of radiation, and waves of cosmic energy collide with this solar-made shield, causing it to ripple and pulse. By examining these interactions, scientists are starting to see the heliosphere as more than just a local phenomenon. It's a microcosm of how similar stellar systems might interact with their galactic neighborhoods. These insights have implications for the search for habitable planets, as they reveal how a star's activity and its heliosphere influence the likelihood of life thriving within its system. Moreover, the probes have highlighted how even subtle changes in the heliosphere's boundaries can have ripple effects throughout the solar system. For instance, shifts in the intensity of the solar wind can alter the structure of the heliosheath, impacting the movement of cosmic rays and particles. These changes, though seemingly distant, could affect Earth by modulating the amount of cosmic radiation reaching its atmosphere. Over geological timescales, such variations might have even played a role in Earth's climatic shifts, tying the heliosphere's dynamics to the history of life on our planet. Heliopause, once thought to be a clear and definitive edge, is now understood to be a transitional zone full of surprises. The instruments recorded a rich tapestry of data, revealing layers of turbulence, fluctuating magnetic fields, and unexpected waves of energy. This chaotic zone is far from static. It's a dynamic interface where the solar wind meets the galactic tide. Understanding this interaction is key to unlocking broader cosmic mysteries, from the behavior of other star systems to the movement of interstellar material across the galaxy. Exploration of the interstellar medium has even touched on the nature of magnetic fields in space. Measurements of the subtle twists and turns of these fields reveal how they guide the flow of particles and influence the structure of the galaxy itself. These measurements are helping scientists piece together the puzzle of how galaxies evolve, interact, and sustain their complex networks of stars, planets, and nebulae. Looking to the future, the data collected will serve as a foundation for the next generation of interstellar missions. These future probes will likely be equipped with cutting-edge technology, allowing them to delve even deeper into the mysteries of the heliosphere and the interstellar medium. They will build on this legacy, pushing humanity's reach further into the cosmos and continuing the quest to understand our place in the universe. Are we truly prepared for the cosmic realities Voyager has unveiled? Or are we underestimating the universe's dangers? Share your thoughts in the comment, like, and subscribe to join the debate.